Hello, Bachu. So first, let's read out the question. Two thin rods of length L1 and L2 at a certain temperature are joined to each other end to end. The composite rod is then heated through the temperature of theta. The coefficients of linear expansion of two rods are alpha 1 and alpha 2 respectively. Then the effective coefficient of linear expansion of the composite rod is. So for this, let us look to the solution. But before of that, let's see the key concept that we are going to use here for this question. So generally, we are talking about the coefficient of linear expansion, right? So coefficient of linear expansion having the formula of in the form of length as L dash is equals to L in bracket 1 plus alpha times of delta t, where L is the initial length of that rod, we can say L dash is the new length which we got just due to change in the temperature. Alpha is the coefficient of linear expansion, delta T is the change in temperature. Now, as you can see that we are given the two thin rods of length L1 and L2, okay, are joined each other end to end. So let's suppose this is nothing but what the first rod, let's say having the length of L1, and let's suppose this is what the second rod having the length of L2. Both are joined together end to end. So as you can see that we got a composite rod whose length will be L1 plus L2 here, right? Now for first rod, the coefficient of linear expansion is given to us alpha 1, and for the second rod it is alpha 2. So what we have to find? We have to find the effective coefficient of linear expansion for this composite rod. So for that, let's suppose the effective coefficient of linear expansion is alpha effective here. Now by using the formula, what we are going to do here, when the temperature will change by the means of theta here. Okay, so there will be an expansion into the length of the rods. Okay, now let's say the change in length of this composite rod is del of L1 plus L2. This should be equals to the change in the first rod length, that is delta L1, plus change in second rod length, that is delta L2. Now by using the concept formula, we can write down here it as initial length was L1 plus L2, this times of 1 plus, for composite rod, coefficient of linear expansion is alpha effective. And now see, delta T is given to us equals to theta, so we substitute here theta. This should be equals to delta L1 can be written as L1 times of 1 plus alpha 1 theta, plus delta L2 can be written as L2 times of 1 plus alpha 2 into theta. Now if we open the brackets by multiplying this two inside, so what we get, L1 plus L2 plus L1 plus L2 times of alpha effective into theta. This should be equals to, now see, L1 into 1 L1 and this L2, this we can combine like L1 plus L2. Okay, this we can directly combine, plus what is remaining, L1 alpha 1 theta plus L2 alpha 2 theta. Now as you can see that this L1 plus L2 we can cancel out from both of the sides. So further what we get L1 plus L2 times of alpha effective into theta. This should be equals to, now see, I can common this theta here, so this will become L1 times of alpha 1 plus L2 times of alpha 2 theta. Now this theta can be cancelled out from both sides. And finally, as we required here, the effective coefficient of linear expansion, that is alpha effective. So this will be equals to L1 alpha 1 plus L2 alpha 2 by L1 plus L2. And see, this is nothing but what asked by the question to find out. And this we have found by using the coefficient of linear expansion formula. Now let us take the option. So option D will become correct answer for this question. So this is the required solution. I hope you understood it well. Best of luck. Thank you.